and action. So the main purpose of today's lab is about making a graph. I know from experience that some of you will never quite figure out how to do a graph. But it's still my hope every semester that this is going to be the class where everybody understands how to make a graph. All right, so.
Did they do graphs and statistics? I can't remember. Maybe not.
I've never done formal statistics course. So.
Well, it's new. I took it because it's a requirement.
Statistics I have is stuff I picked up on the streets. Street statistics. Otherwise known as physics. All right. Well, the statistics classes, it seems like all the books assume everything's a Gaussian curve, and reality is not a Gaussian curve. Always. All right, so if in this particular one, I think the first graph you're going to be doing is circumference versus diameter. Probably the biggest mistake people make on this one is, one, not having a title, but this is going to be the title. When I say plot something versus something, I'm expecting that to be the title, circumference versus diameter. The word graph doesn't show up in front of it. I will be able to tell very quickly that it's a graph, so you don't need to tell me. But circumference versus diameter should be the title of everyone's first graph. And let me just confirm, could I borrow this for just a second?
Yeah, go ahead.
Yes, make a proper graph of the measured values of circumference versus diameter. Circumference versus diameter is the title of the first graph. The second graph will have a title of average time squared versus distance traveled. Thank you. So, for the people who write down, who do the title correctly, the biggest mistake I see is misspelling circumference. And it's quite possible I misspelled it up here. Please make sure you spell it correctly. And at least when you do the axis label, one of them is going to be circumference. People are not always consistent with how they spell the word in those places. But then there will be axes. And you'll do this in some sort of spreadsheet program. If you want to do it by hand, it's not unallowed, but I am expecting draftsman quality. So you're not sketching that one loosely if you're doing this by hand. I would think a computer program, Excel, open office spreadsheet, LibreOffice spreadsheet, Google Docs, my least favorite of the non-Microsoft products. They will do probably a much better job with straight lines than you will by hand. But I have had draftsmen before, and that works just right. All right, so there's my title. The way this is set up, this first one, this is the dependent variable. And this is the independent variable. Now, in this particular case, it's a little bit sketchy which one's dependent or independent from a philosophical point of view. It's clearer on the second one. But when you're doing the title, it's officially the dependent versus the independent variables. In the second one, where it's a lot clearer, you're doing, I think it's time squared versus distance. Now, the actual title pull from the lab. This is just the quick and dirty here. You are going to set the distance. You're going to say, I'm going to see how far this thing was going to, how long it's going to take to roll 50 centimeters or whatever it happens to be. So this is independent between the two variables, but this is the one that you control. This second one is dependent upon the distance. You are not saying, how far is it gonna go in 5 seconds? You're gonna go, I'm rolling at a certain distance, let's figure out what the time is. This depends upon that. So this is the dependent variable.
Yeah,
Yep.
I'm getting there.
Okay. Yep.
The independent, it seems backwards. The independent one is the one you're manipulating and changing. And then the dependent is the one that you're actually measuring.
Yeah, it's in reference to the variables. Yeah, does seem odd to me to call it the deep, independent variable when it depends upon you. But it's not dependent upon the other variable. Now, once you have the title, the first word here, circumference, the first word in the title is closest to the vertical axis, and so it goes with this axis. This is my circumference axis. And so I would expect to see the word written out there. Space, parenthesis, unit. I think it's centimeters in this particular case. Whatever the appropriate unit is. I do expect a space there, and the unit should be in parentheses. But one of the reasons for that, if I have an axis here, if this is distance, ten to the third meters, and that's 1, 2, 3, 4, 5. What is in parentheses assumes goes after it. So this is 1 times 10 to the third meters. So this would represent 1,000 meters. This would be 2,000 meters, 3,000 meters, because this is tacked on after it. If instead, actually I'm going to put a little time symbol in there. If instead we had written, got my axis here, 1, 2, 3, 4, 5. Distance times 10 to the third meters. If we run it like that, that means if I take the distance, multiply by 1,000, I'm gonna get this number right here. So in this case, this number right here represents 1,000th of a meter, or a millimeter. This would be 2 millimeters, 3 millimeters, 4 millimeters. So where the units are, what's in parentheses, matters.
Okay.
Dr. Fox?
Yes.
So is that like scientific notation, basically? Where it says distance times.
Yeah, I mean, it just happens to be. I could have written out the number. I was not necessarily
Yeah.
advocating scientific notation there.
Okay.
All right, this down here will be distance, diameter, the other D word. With a space followed by those units. If you're doing this by hand, I'm expecting that the increments here will be even, so you're going by 1s, 2s, 3s, whatever it happens to be, 0.1s. So 1, 2, 3, 4, and so on, and then going along this axis, let's just say 2, 3, 4, 6, whatever the numbers happen to be. Now, if you're using a program to do this, then it's automatically gonna know this stuff, and you don't have to think about it. If you're doing this by hand, you don't have to think about this. You're gonna get the plots pointed down. We'll now assume that you are using a software to do this. You'll do a scatter plot, no lines. Basically, when you do the drop down, you're gonna see the symbol of something like that. In some cases, that'll be it, and it'll automatically do the scatter plot. Other cases, what it's gonna do is then give you another display of menu where it's going to show you various forms of it. You want the one with no lines. But if you do the one with the lines, what it's gonna do is it's going to start suddenly plain connect the dot here. It's not a connect the dot exercise. Alright, so it'll come down and you'll get various points there. Once the data points are in place, I don't need to see the data points labeled, because if I want to know the exact data point, what I will do is I will look back at your data, the table where the numbers actually are. Then you're going to add trend line. And what I find out, just sort of as a side note, in Excel, they have trend line as a single word, but in Microsoft Word, if you type in trend line like that, it says it's misspelled. You're going to add trend line, and then there's going to be two check boxes you need to make sure that you check. Show equation, and show R squared value. My problem with Google Docs, and I've accepted it, unless it's a formal report, but in Google Docs, they don't really show the equation, they show the right hand of the expression. Because you have the generic line equation of y equals mx plus b, and what Google Docs is just shows you that part of it, unless they change it. So it's going to come through and it's going to pick a line here, and then it's going to come flash up R squared equals 0.8943, and then depending on what software you're using, if you're using Excel, it'll be y equals some number x plus some number. If you're using OpenOffice, it'll not have a y there, it'll show fx equals. Please take this out a good number of decimal points or significant figures. I'm not specifying it, but Excel sometimes will just round off for some bizarre reason. You know, it might be 1.57326 and it just says, 2. And I haven't quite figured out why it does it sometimes and not other times. Probably because I just don't mess with Excel, you know. But please go through and make sure there's, you know, a couple of significant figures in it. And that would be the graph right there. Questions? Yes.
So we're only gonna graph the circumference versus diameter chart that you have in the middle?
You'll definitely be doing two graphs, that's one of them.
Okay.
The other one is, I think it was time squared versus distance, or average time squared versus distance. Other questions at the moment? All right, some specific things about this lab. When finding the circumference, you are to measure the circumference. Do not calculate the circumference. The whole point is, if you calculate the circumference, you're going to get points that fit perfectly. You'll have an R squared value of 1, and whenever I see R squared value of 1, I get really suspicious, because then I think they just calculated this. They didn't actually measure it. Now, I did have a group last year, the year before, at some point pre-pandemic, that did the measurements. While they were sitting there, somebody plugged it into Excel or whatever spreadsheet program they were doing, they had an R squared value of 1, and they called me over just to say, hey, we measured it, this is what we did. I just want you to know that we did not calculate this. And okay, I saw it, I was good with that. I am expecting that the R squared value is going to be somewhere 0.95 or higher probably. 1 is perfect fit, 0 is I'm not even sure if 0 is possible, but the closer you are to 0, the worse fit it is. And the other one, you know, R squared value could be a lot of things. It should be somewhere, probably, would expect it somewhere about 0.9 or higher for the R squared value here. When you are picking out the items for measuring the diameter or circumference, please make sure they're all roughly the same ballpark. Don't pick a whole bunch of things that are about roughly this size, like 4 things this size, and then something that's this big. You know, pick things that are all, you know, I mean, it can spread over that, but, you know, pick things with increments in between. So I don't want a cluster of 4 and then one sticking way out here. And, right, so I think it's now where's the equipment. There are round things all over the place, so feel free to
Round thing?
round things. The balls for rolling down the track, there's a box over here marked balls. And there's a container, I think an M&M container back there with a whole bunch of round things with spheres. As far as rolling down, there are a bunch of inclined planes over there to the right of the table, which has the triple beam balances on. Just to the right, there's tracks there, which have the convenience also of having the length on the side. I think there's up about 1.2 meters. So you've got something already measured there. If you don't want to do that, if you want to just tilt the table and do that, meter sticks are over here. And as before, when you're done, put things back. I probably have forgotten something, so I'll yell it out when I remember it. And we are missing one, I think. So we have 19. Yep, so we're missing one. So I'm picturing 4 groups of 4 and a group of 3, but who knows if that vision will come true. But above all, don't forget, rejoice, because this is physics. And we do your thing, get your groups. Does not have to be the same group as last time. Nathan.
I can
You guys wanna do the same group?